This is Algebra 1, Unit 10, Lesson 3 on measures of central tendency. In our day-to-day activities, we deal with many problems that involve related items of numerical information called data. Statistics is the study of sets of such numerical data. When we gather numerical data, besides displaying it, we often want to know a single number that is representative of the data as a whole. So we want to make a conclusion based on our data. So we call these types of numbers measures of central tendency. So the two most common measures of central tendency are called the mean and the median. So we're trying to use the mean and the median to describe sets of data. All right, so mean is the average. When you take the average of something, you add them up and then divide by the number of things that you have, and you have the average. All right, and then we did yesterday in the notes that a median is the middle number. All right, so what we're going to look at is the mean and the median for this set, and I'm going to show you how to do it on the calculator. All right, a survey was taken amongst 12 people on the number of passwords they currently have to remember. The results are shown below. State the median number of passwords and the mean number of passwords to the nearest 10th. Okay, now normally for the mean, we would add all these up and then divide by 12 because there's 12 numbers there. So we're going to have the calculator do that for us, and we're also going to calculate the median. The median, remember, is the middle number. So if I grab my calculator, you want to press Stat, Edit, and then we want to enter the numbers. So it's going to be 0, 1, 1, 1, enter, 2, 2, and then 4 threes, 1, 2, 3, 4 threes, and then a 4 and a 6. 4 and 6. Okay, so that should be 12. Yeah, so I'm on the 13th one and it's blank, so there's all my values. All right, now remember to figure out the mean and the median. You have to go to Stat here, go to Calc, and then pick var stats, number 1. All right, now remember our list was in L1. Frequency list should be blank, and then go down to Calculate. Press Enter. All right, now median, we found yesterday, is down here, is going to be at 2.5. So your median is at 2.5, which is actually right here. That's your median. Okay, so notice there's 6 on one side, 6 on the other side. All right, now the mean or the average is actually the symbol X bar. That's the mean. So if we look at our calculator, the very first value on here is X bar. All right, and it said rounded to the nearest 10th, so your mean is going to be approximately 2.4. All right, so notice the mean and the median are pretty close. So that means that the data is pretty evenly spread around the middle. All right, so if you look at your numbers here, they're pretty close together. So that works out pretty well. So mean is X bar, which is the average. Median is the middle number. All right, before I move on to the next thing, I want to clear out my, my list on this. So remember to do that, you press Stat, number 4, clear the list. And I'm going to pick list 1 I want to clear. So I press second and 1. Remember, it's in blue right here. It tells you L1. Press Enter, and it should say Done. So now it is blank. All right, so now let's try exercise 2. Students in Mr. Okafor's algebra class were trying to determine if people speed along a certain section of roadway. They collected speeds of 20 vehicles and displayed in the table below. All right, so notice this is a table. This is actually a frequency table. When you saw 29, one car went 29. How many cars went 33? That would be 2. 34 would be 4. 35 would be 5. There'd be 5 35s, 3 36s, 2 38s, 39s, and 54s. Now, it could be a kind of a pain in the neck to have to enter 129, 2 33s, 4 34s in one big list. That would be a lot of typing. So what we are going to do is we are going to create a frequency table to do this. Frequency table means the number of times things happen. So what we're going to do in our calculator, this is going to go in L1, this is going to go in L2. So we press our calculator, Stat, Edit. All right, now L1 and L2 should be blank because we just cleared them. All you have to do is put in the numbers, 29, 33, 34, 35, 36, 38, 39, and 54. All right, so L1 is the speeds, and then L2 would be the frequency, how often that happened. So this was 1, 2, 4, 5, 3, 2, 2, 1. Okay, so notice these match up just like it's on the paper. You want to make sure they match up. All right, so now if I want to calculate the mean and the median, I go to Stat. I'm still going to go to Calculate and var stats. All right, but remember that this is going to be a frequency list in L2. L1 is the list of the numbers. L2 is how often they happen. So I have to go down to frequency list, and I have to put L2 there. All right, L2 you find by pressing the blue second key and the number 2 key, and then go down to Calculate. All right, so that will take, I have L1 and I have, in L2 I have how many of each one I have. So that way you don't have to type in every single number that many times that you have. All right, press Enter. All right, what value is our mean? This would be our mean. So X bar would be the mean, is going to be X bar, which is 36.1. So the average speed is 36.1. And the median, if we look at our calculator, we have to scroll down here. The median is going to be at 35. Okay. All right, so the mean is 36.1 and the median is 35. So the average speed is 36.1, the mean is 35. Okay, now let's take a look at our numbers here. The speed limit along this part of the highway is 35 miles per hour. Based on your results from Part A, is it fair to make the conclusion that the average driver does speed on this roadway? Okay, the average driver would be the mean. All right, what was our mean? Well, if we look at our mean here, we have 36 miles per hour, approximately 36.1 miles per hour. Okay, the mean is at 36.1 and the median is at the speed limit. Well, why is the mean and the median different? Well, they're close, but they're a good mile per hour off. So one is speeding and one isn't. Well, if we take a look at our values here, when you find the average of something, you add them up. Now, all these numbers are pretty close except for what number? Well, the 54. The 54 will affect the mean because when you add 54, it's going to raise the mean up. So actually, the median is a better way to do the conclusion. So, is it fair to make the conclusion that the average driver does speed on this roadway? It's no. All right. Even though the mean is 36 miles per hour approximately, it is affected by the 54 miles per hour. All right, now the median is the middle number. All right, so the median means 50% of the drivers should be driving 35, if it's at the middle of the number, right? Okay, so if I go to 35 here, how many drivers are driving 35 or less? So if the median is 35, that means that 5 and 4 is 9, and 2 is 11, and 1 is 12. 12 drivers out of 20 are driving below the speed limit. Okay, so the median is actually better. So the average driver, no, because it's making the mean go up because of the 54. All right, now let's move on to a statistical study. When you're doing a statistical study, what you need to know is you have to know information about a group, but you can't do every single person all of the time. So when you're doing a statistical study, you have to make sure that you do a sample or portion of the items being investigated, but you want it to reflect the overall population. So you have to be careful about bias. All right, so what would make your answers be one way or the other? So let's take a look at this problem. To determine which television programs are the most popular in a large city, a poll is conducted by selecting a sample of people at random and interviewing them. Outside which of the following locations would the interviewer be most likely to find a fair sample? I explained your choice and why the others are inappropriate. Okay? So, if I wanted a fair sample, where would I stand outside and do this? Well, I would probably pick a grocery store because in a grocery store, everyone uses this. So it doesn't matter what they like or do not like. In a grocery store, you're going to get a random sample of people. Baseball stadium, probably people that like sports would watch that. For a concert hall, probably people that like music would watch music channels. And a comedy club, if they liked the comedy channel or sitcoms or whatever, they'd probably like there. But everybody has to go to the grocery store. So you want to be a fair sample, you would pick a grocery store over that. All right, exercise 4. Trong is trying to determine the average height of a high school male student. Because he is on the basketball team, he uses the height of the 14 players in the team, which are given below in inches. Calculate the mean and median in this data set. Round any non-integer answers to the nearest tenth. Okay, so I want to know the mean, and I want to know the median. Now, to save time, I already entered this in my calculator so we can have it. So let me grab my calculator. I entered them all in L1. I just pressed Stat, Edit. I cleared everything out and just put it in L1. Now, I want to go Stat, Calc, var stats, and I want L1. I don't want L2 because I don't have anything in L2 anymore. So I'm going to clear that and press Calculate. So my mean is going to be 74.6 because it said round to the nearest tenth. And my median, if I scroll down here, is 74.5. So those numbers are pretty close. So this is going to be a pretty evenly spread out value. All right, now, is the data set a fair sample to use the average height of high school male students? All right, now who did he use? Well, he used the basketball team. So is that a good sample of average height? No, because basketball players tend to be taller. So that would not be a fair sample. Now, if he'd stood outside the cafeteria maybe and measured heights, that might have been a little better because everybody uses the cafeteria. So basketball players tend to be taller than average. So that is not a fair sample. All right, so let's look at our last topic here. Data sets can have members that are far away from all the rest of the data set. These elements are called outliers, which can result in a mean that does not represent the true average. Basically, the outliers will make the mean go up or down because it's way outside what we have. So let's take a look at this problem. In Mr. Petrovic's advanced calculus course, 8 students recently took a test. Their grades were as follows. So calculate the mean and median of this data set. Okay, so I already put this in my calculator. So I press Stat, Edit. You can see they're all here. Now Stat, Calc, var stats, and I just wanted an L1, so it's all there. So I go down to Calculate, and I have the mean is 81.75, and the median is 86. So that's quite a difference. So the mean is 81.75, that's X bar, and the median is going to be 86. So what score is an outlier in this data set? What score is making the mean be so much different from the median? Well, it would be the 45. If you do the 45 on that and add in 45, that's going to lower your average. So which value, the mean or the median, is a better measure of how well the average students did in Mr. Petrovic's quiz? Well, it would be the median. If I wanted to look at my values here, the 45 pulls the mean, the average score, down to about here. Now, most of the data falls way above that. But if I look at 86, most of the data falls around that more. So the median is actually going to be a better measure. Okay, your homework for today is to do the worksheet that goes along with this. You're welcome to borrow a calculator during study hall, but make sure you bring it back.